Alrighty, this video is going to be fun. We are going to be looking at a new feature of ES2015 that should be very, very familiar to people who work with other languages, particularly C#. We're going to be looking at iterators and generators and a new form of looping that's available in ES2015. So again, just to remind you guys, I do have my Babel compiler watching my scripts folder. I do have my HTTP server on the public folder, and I did import the Babel polyfill. So if you haven't done that, watch the beginning of the previous video where we get that set up, because you will need the polyfill for what we're about to do. All right, let's go through our little ceremony here, and I'm going to create 07 iterators, 8.html, and it's going to include 07 iterators.js, and then I'm going to come into source scripts, new file, 07 iterators.js, and then I'm going to go ahead and split that, and I'm going to open up scripts iterators. All right, so we're all ready. Not quite yet. I almost forgot that. Otherwise, Visual Studio Code will yell at me for reusing the exact same variable names and class names like I've been doing. Like I said, my creativity ran out quite a bit ago. Okay, so a really simple example to kind of illustrate the first concept of what an iterator is, or an iterable is to go ahead and show something that you guys might have actually ran into an issue of in the past. And that is, if I go ahead and say, let's just say const elements equals document.query selector all, and I'm just going to pass in star to select every single element in the document. And let's say I want to go ahead and loop over all of these elements and print them out. So something you might do is you might say for let element in elements, and you might say something like, let's go ahead. So remember, when you do a for in over an object, you're going to get the key back for everything. Like, for example, if I console logged out element here and I ran this code, let's hop into iterator.html. Notice how I'm getting a key here for all the individual items. In this case, the indices for each individual item. So, of course, to actually access the particular element, we'll just say, we'll rename this to index, and then we'll say const element equals elements at index. Let's say I wanted to print out the tag name for every single element in the document. So I would say element.tagname, right? So tag name is the property on the elements that'll print out the name of that element. And if I came back here and hit F5, notice how I get my HTML, I get my head, I get my body, which if you recall is pretty much all that's in this document. I get my 3 scripts, but then I get 2 undefineds. And why does that happen? Well, that happens because I'm iterating over an object, and that object has additional properties on it. So finally, after so many years, JavaScript finally supports the ability to iterate over these special objects, such as a collection of elements, and get back what you want without having to resort to different hacks. So let's see how we can do that. I know this might not be making a whole lot of sense, but once I show you guys this, hopefully it will. So what we're going to do here is I'm going to say for let element, then I'm going to say of. Notice how I say of and not in elements. I'm going to say console log element tag name. And then I'm going to come back here, hit F5, and notice how I get my proper result back. So this was the improper result because we got these 2 undefineds, things that were not elements. This was the proper result because we did not get the unwanted elements. So what exactly changed? Well, you probably noticed it for a split second, but a whole lot of scary stuff appeared on the right-hand side here in our compiled code. So, yeah. This simple little 3 lines of code turns into this resulting code. Now, like I said, once browsers actually support the for of loop, this won't be necessary. But for now, this is Babel going out and compiling the for of loop into a way that older browsers understand, or even modern browsers that might not support this construct. And I'm not too interested in talking about exactly what this code is doing here or why it's structured the way it is. All I'm going to say here is that this elements is a array that's returned, or a special element returned by query selector all, but it has this special property attached to it. It is an iterable. It has special logic for when you want to iterate over it. If you are familiar with Java, it's similar to an iterator. If you're familiar with C#, it's similar to an enumerable. So when I loop over this object, it's deciding what to give me. It's deciding what things to return in that loop, as opposed to the for-in loop, which blindly iterates over through every single property on an object. That's what a for-in loop does. It loops through all the properties on that object, including properties defined by the prototype of that object, which is why we'd normally use hasOwnProperty here. But when we loop over an iterable and we use the for-of construct, what we get is whatever this object has been coded to give us. So you can think of it like this. When we do a for-in loop, we're blindly looping through all the properties on an object. When we do a for-of loop, we are asking this object, hey, so you give us collections of things. That's cool. I'm going to ask you what you want to give me. And so you're now responsible for giving me that data. And if you don't think something's important, don't hand it to me. And that's pretty much the concept of the for-of loop and iterables. For example, arrays are iterables. So for example, if I were to go ahead and say const array equals 1, 2, 3, 4, 5, 6. Again, creativity is running out here. For let item of array, I can go ahead and say console log out item. And again, a bunch of this scary code appeared, but that's fine. Coming back into Chrome, we will see that it did properly loop over that. So a for-of loop will work with arrays, and it'll also work with objects that have a concept of being enumerated. So what if I had an object that had no concept of being enumerated over? Well, let's take a look at that. I'll do my classic const person, and I'll say name is Nelson. Yes, I'm boring. Now let's say for let item of person console log item. So what do you think will happen here? Well, if I jump over into Chrome and hit F5, I get an error. Ooh, hey, look, a symbol. We'll talk about that in a moment. So I get an error because the person object has no concept of being iterated over. Again, the difference between for-in and for-of is for-in loops over all the properties blindly. For-of asks the object, hey, what do you want to give me? And in this case, a person has nothing to give. There's no, the person has no concept of being looped over. This is actually a great thing because, generally speaking, us as object designers, when we design a class or an object, we want control over whether or not we want them to be iterated over in the first place, and if we are iterated over, what do we give back? Alrighty, I'm about to write a bunch of scary code that's going to look really ugly, and it is really ugly, but then I'll make up for it by showing you how you can rewrite it in a much better way. So once you see this code, don't, close the video quite yet. But it is kind of ugly, and it comes into, I kind of want to show you guys sort of the internals of how an iterable object works. And it kind of plays off what we're seeing right here. So yeah, let's make an iterable object. I'm going to make an iterable object that counts from, let's say, runs 5 times and returns the current index times 5. Really simple stuff. Kind of not really a useful example, but at the very least, you guys will see the actual syntax involved with defining an iterable, and it might make the concept of an iterable make more sense. So I'm going to make an iterable, and it's going to be an object. And then I'm going to use some interesting syntax here. I'm going to say symbol.iterator, and then I'm going to make this a method. So what is going on here? Well, remember in the last video, I said that symbols allow us to create private fields, but they also allow us to hook into the internals of the JavaScript engine. So the JavaScript engine will have special symbols that we can take advantage of. If you're familiar with PHP, you might know of magic methods like _get or _call, where the PHP designers decided to, okay, so you want to create a special method that is only understood by the runtime and shouldn't be called directly. Well, we'll just make this convention where we'll give it 2 underscores in front of it. Well, in JavaScript, what they did instead was they used symbols and built-in symbols. So that way we can never accidentally call this function. The only way to call this function is to knowingly call the iterator function on this object. The next thing is in the last video, you saw me using symbols for just fields. Well, this is me using symbols for a property. Again, I'm just going to remind you guys, when you see the square brackets, we're doing a computed property name. And the value of that is symbol.iterator, which is a built-in symbol. And then we have the parentheses right there, which makes this a method. Of course, I could have done this if I wanted to, but that's just boring and ugly and redundant. So anyway, let's go ahead and write our iterator. Our iterator, let's say, we'll say let index equals 0. Then I'm going to return an object. And that object is going to have a special method on it called next. Next is going to increment our index, and then he's going to return an object. And then that object is going to have two properties. Value is going to be index times 5, and done is going to be index is greater than 5. So yes, I do have an object that has a method that returns an object that has a method that returns an object. I don't know, welcome to JavaScript. But I told you this would be ugly. Basically what's going on here is we're creating this special little thing that's picked up by the JavaScript runtime. And then I'm creating this kind of like this local variable sort of thing here in this scope, and I'm returning the actual iterator. So the actual iterator is this object right here that I'm returning, and he has a method on him, and that method is called next. So basically what happens is when we iterate over an iterable, just like how IEnumerable works in C#, and just like how iterators work in Java, and how iterators work in pretty much any language that they're implemented in. The for in loop, or for of loop, is going to invoke next. And next is going to return an object. It's going to return an object with two properties. A value, which is the thing that goes in here. So remember, the for of invokes next, gets this object back, and then whatever's in the value property gets set to the thing inside of here. And then the done property is, well, self-explanatory. If the for of loop receives an item from the next method or next function that has a done property set to true, then the loop is done and it's over, and execution goes on. And again, if you really wanted to dig into this code right here, you'll see exactly what I'm talking about. So notice how it does invoke next, it does check to see if it's done and all that stuff. So once the for of loop actually gets implemented in modern browsers, then this code will be unnecessary, of course. But this is a great way to see how this feature is implemented behind the scenes. Anyway, that's enough talking. Let's go ahead and see how this behaves. So I'll say for let item of iterable, and I'll say console log item. So what do you expect the output to be? Well, let's hop over into Chrome, reload. Check that out. 5, 10, 15, 20, 25. So again, I increment the index on every iteration. For the value is index times 5, so that's what's returned into this item. And then the done dictates when it stops. And it stops when the index is greater than 5. Now, of course, I could come here and say done equals false, and just hard code in false there. What do you think this is going to do? Well, not good things. It's just going to sit there and spin and spin and spin because the iterator is never reporting that it's done. And I'm going to stop that before I run out of memory or something. Go away. Oh, I'll be right back. All right, I just had to use the Chrome Task Manager to kill that poor tab that was destroying my JavaScript engine. Anyway, before I do that again, I'll come back here and actually fix this code. Set it to index equals greater than 5. And load that up again. And be sure to do a hard reset. I gotta clear my cache, don't I? It just loaded in the old version. There we go. And we're back in business. Yeah, pro tip, don't run infinite loops in JavaScript. It's never fun. Anyway, the point is we have a iterable that the for in loop or for of loop is executing. And this is great. This is really demonstrating that the concept of the for of loop is the object we're iterating over is what's responsible for giving us the data, which is awesome because we can compute data. We could compute the Fibonacci sequence if we wanted to, which I think will be the next example, in fact. But Again, if we did not have this simple iterator method, this code wouldn't work because the for of loop depends on that method existing. All right, so I promised you guys a way to create an iterable that doesn't make your eyes bleed, and let's go ahead and talk about that. The feature is called generators, and generators are practically identical to iterator blocks in C#. If you're familiar with C#, you know the yield return, yield break stuff. Basically the exact same concept. And you're about to see some seriously scary code on the right-hand side here. But I'll talk about that as well. So let's create a generator. A generator is a function, but it's a function that's declared in a very special way. Basically, you start off normally by typing in the word function, as you would any other function, and then you type in a asterisk. And then you give it a name. Let's give it a name of fib. And let's give fib a parameter. I'll say max equals 10, so we can decide how many Fibonacci numbers we want from this iterable. Okay, so the only difference between this and a normal function is that it is a generator. We know it's a generator because of the asterisk. Not sure I'm a big fan of that syntax, but that's just the way it is. It's been standardized. It's what we're going to have to live with. So, so let's look over to the right for a second. We can see that even though our fib function is empty, Babel created a whole bunch of stuff. And we're going to see this grow a lot, and I'll talk about what that's doing after I write this method. So, so actually, no, I want to keep this simple for now. Let's make this a really simple Fibonacci generator. And basically, I'm going to cheat. Okay, so then I'm going to say for let item of fib, and let's just invoke fib with no parameters, console log item. And let's come back into Chrome, and I'm going to reload here, and we see 11235. Okay, obviously I cheated. I just calculated the sequence manually, but it gives us an opportunity to talk about this guy, yield. So what is yield? Well, let's come back over here and look at this, this spaghetti that's been generated by Babel. Basically, the concept of yield, and you'll be familiar with this if you know C#, is it creates a state machine. It's basically creating this next function, but it's slicing it up. So every single invocation of yield slices this method or function into a state. And we can see this little state machine right here. So basically, when I say yield 1, the function stops. The function's done. And then it returns a value of whatever I yielded with a done of false. Only does done become true by this iterator when that only happens when it's the entire method is finished. Unfortunately, we can't see all of the code Babel is using because it's taking advantage of the regenerator runtime, which is part of the polyfill that we included. So we can't see the actual entirety of this example on the right-hand side. There's a little bit more code to it. But let's go ahead and make this more interesting. Let's actually calculate those numbers. So I'm going to say let last 2 equals 1. Let last 1 equals 1, and I'm going to say for let I equals 0, I smaller than max, I plus plus, and we're saying const current equals last 2 equals last 1 plus equals current, and then yield current. So a really straightforward loop-based Fibonacci algorithm. And we can run this to verify its output real fast, and we see the proper sequence being printed out. 1, 1. There's 2 1s here. You know that by the little 2 there. 1, 1, 2, 3, 5, 8. And all that fun stuff. We look over here, and we see things are a bit more complicated. There's actually people way smarter than me are the kinds of people who build these state machines or how they're generated. Honestly, like taking this code and chopping it up to where every time we invoke this method, another thing is yielded. It's pretty brilliant, honestly. But it makes writing these iterables really, really simple. And so we're able just to create this straightforward generator, and we just yield out when we want to send back data to the for loop. And that's what happens. I can prove this by saying console log calculating current. Come back here and reload. Check this out. that console log is being printed out in between iterations of the for if loop. So I think that's pretty excellent. So as you see, the method is actually getting paused. It's getting paused mid-method to yield the data back into the loop. Anyway, that's how generators work. Not a whole lot more to say about them. They're pretty straightforward. Iterators might take a little bit of time to get your head around, especially if you're not familiar with the language that has built-in support for that sort of pattern. But they're really important. They're really awesome. Babel supports them very well. And one day, you know, we won't need Babel for this particular thing, but until then, we can definitely use it to take advantage of this feature. I think this wraps up this video, and we'll see you guys in the next one.